So the problem is asking how many grams of oxygen. Okay, so now we're asking grams of oxygen are in C6H12O6, which is glucose. Okay, and I can tell you how many grams of glucose I have. Well, the problem is there is no conversion factor that will tell you the relationship between the grams of an element to the grams of that compound. So we're going to have to go through a couple of steps. This is an example also that's in your textbook. Okay, so the conversion factor, one of the conversion factors I do know what the relationship between the moles of oxygen to the moles of glucose is going to be. I know that there's 6 moles, okay, because there's a C6 to every 1 mole of this compound, C6H12O6. So I can write down this conversion factor. I also know that there's a relationship between the molar mass and the atomic mass. So if I know the atomic mass, I also know the molar mass. And the molar mass, the units are going to be grams per mole. So the molar mass for carbon is going to be 12.01 grams per mole. Hydrogen is going to be 1.01 grams per mole, and oxygen will be 16 grams per mole. And again, this is coming from the periodic table. Right. All this information here comes from my periodic table. I just look it up. It's the number. It's going to be the number underneath that particular symbol. Okay. Okay, so what I'm going to do is calculate the molar mass for the glucose, and what I do is I sum up the molar mass for each individual element. I have the 6 because I have 6 carbons, I have 12 because I have 12 hydrogens, and I have 6 again because I have 6 oxygens. Okay, so this represents the carbon, this 12 here is coming from the hydrogen, and this 6 here is coming from the oxygen. Okay, and followed by that I have the atomic mass, or the molar mass, the grams per mole for each one of those elements. Multiply, add those together, and I get an answer of 180.18 grams per mole, which is the same thing. It's equivalent to saying I have 180.18 atomic mass units. Okay, because this would now allow me to go from moles to grams. Okay. But I also need the molar mass of oxygen, which is going to be 16. Okay, so I have all the conversion factors I need to be able to determine how many grams of oxygen it's going to be in 13.5 grams of glucose. Okay, so starting again with what I'm given, which is the grams of glucose. And what I'm going to do is convert this from grams to moles. You do this by using my conversion factor, right? 180.18 grams of C6H12O6 for every 1 mole of C6H12O6. Okay. This is the conversion factor which I had on the previous page, which tells me that the molar mass of glucose is 180.18 grams per mole. Okay, so that's the same as me writing a 1 underneath this for the moles. I'm going to put the grams on the bottom, and I'm going to put the moles on top so I can cancel. Okay? Because I want to be left with the number of moles of C6H12O6. Because I have a relationship, or I know the conversion factor between the moles of C6H12O6 to oxygen. Okay, I can tell you how many moles of oxygen is in there, so I'm going to use this knowledge now to do the next step. So I get my answer 0.0749 moles. Okay, so 13.5 grams is going to be equal to 0.0749 moles of glucose. So I take this new value I have in terms of moles, and I'm now going to convert this and determine how many moles of oxygen I do now have. So I'm going to go from moles of C6H12O6 to moles of oxygen, which we have done in the previous problem. Okay? And I put 1 mole of C6H12O6 on the bottom, and I put the 6 moles of oxygen on the top, because we said earlier that I have 6 moles of oxygen to 1 mole of glucose, and I write it this way because I want the moles of C6H12O6 to cancel. So I'm left with moles of oxygen. Okay, so now I've determined how many moles of oxygen I have in a certain number of moles of glucose. Okay, but I was given grams of glucose. So first I had to convert grams of glucose to moles of glucose. Then from there use the knowledge and determine how many moles of oxygen I have. Now that I have moles of oxygen, I can now convert the moles of oxygen to grams of oxygen. Okay, so I'm converting moles to grams. We had the molar mass earlier that tells me that I have 16 grams of oxygen per mole. So I put the grams of oxygen on top, the moles of oxygen on the bottom, so that I can cancel my units, and I'm only left with grams of oxygen. And my answer is 7.187 grams of oxygen. Okay, or 7.19 grams of oxygen, depending on where you want to do your rounding. Okay, so my answer, for every 13.5 grams of glucose, there's going to be 7.187 grams of oxygen. Okay, so what I had to go through 3 different steps in order to get this answer. Your book does it all in one line, but what I've done here is broken them down into the various steps so you can get an idea of what they're doing in each step. Okay, so for this particular type of problem, whenever you're looking for something, I ask you for the number of grams of one element, and I tell you how many grams of a compound that you have. These are the steps that you need to go through. First, you need to convert the grams of that compound to moles of compound. Okay, and that is done by finding the molecular mass for that compound. Again, you take the atomic mass units for each one, multiply by how many components you have, and sum them together, and you'll know how many grams per mole you'll have, and then you'll be able to do that conversion. Okay. Once I now have the moles of a compound, I then want to convert that to the moles of the element. Okay. And again, you can find the conversion factor for that. We did it in previous problems. And then finally, what I want to do is convert the moles of that element to the grams of that element. Okay, again, using my knowledge of the atomic mass for that particular element, realizing that that is the same as the gram per moles. Okay, and this now will be my answer. Okay, so this problem does require you to do a few steps.